there we go. All right. Welcome to Data Science Club number 29. I think we've got this one and one more that we're going to do before the new year. So today we're going to just finish out what we were planning on doing as far as the Seaborn library, the stuff that was in the Kaggle exercises there. So that's what we're going to do today.
Yeah, we have already had two other videos regarding the Seaborn library. Yeah. It would be a good idea for people who are just watching this for the first time that go through the previous two videos as well, because that would give you a nice progression through the Seaborn library and how to use it, and then come and watch this one.
Yeah. Or you can do them out of order if you like. But yes. That's up to you.
Yeah, the good thing is in each of those videos we were doing different types of graphs. So
yeah. So we're gonna see how much we can get through. Today we will at the very least do the distributions notebook. But if we have time, we'll take a look at the choosing plot types and custom styles. But again, that's kind of above and beyond the basics. So if we don't get there, it'll be okay. But we'll try to make it there. All right. So last time we looked at scatter plots, and today we're going to look at distributions. So we can say this is create histograms and density plots. You can find this tutorial by going to kaggle.com/learn/data-visualization. Or if you just go to kaggle.com and then go under the courses tab, you'll see all the courses that they have there, and you can click on data visualization, and that's where we're at. And so we're going to go to number 5, which is distributions, and we're going to start that up. And it'll probably take a minute to just prepare the notebook.
Alright.
Ooh, very cool. I don't know what that picture's about, but it looks interesting.
Yeah.
Alright. So, we're given a scenario.
Breast cancer tumors.
Each tumor has been labeled either benign, so it's not cancerous, or malignant, meaning that it is cancerous. And let's see. Okay, so there's a link here that you can go to. Looks like a YouTube link to understand more about how to use this data to classify tumors. But we're not doing that. We just want to visualize our data. So we're going to come down here. First thing, we're going to run this setup cell where we're importing pandas and the matplotlib library and Seaborn. All right. And then because we're on Kaggle and they have these nice checker tools, we'll start those up as well. Okay. And so now we're going to load the data. And so this is our first one that we actually have to edit. So we have the file path to 2 different CSV files, and now we've got to read them in. So let's see. I don't remember everything off the top of my head, but I think we're going to use pandas to do that. So it'll be a pd.read_CSV. And then we're going to put the cancer _B file path in there.
Yeah.
And then sometimes it has us do something different, like tell it where the ID column is, but we'll find that out.
Once we run it.
All right, so we're loading these in as 2 separate data frames since we have 2 separate CSV files.
Yep.
All right. So yeah. So it's saying unexpected column in cancer _ B _ data ID. So that means we've got to go back in and tell pandas which column was the ID column.
Yeah, and that was key or something. Serial key, primary key. I don't remember.
Index column.
Yeah.
And then is it just ID like that?
Use the ID column too.
Okay. Well, I changed my error, so it's just saying I need to do that for the other one. So yeah. So you have to add the argument index _ column equals ID. And there we go. All right. Cool. So we've got our data loaded. And now we want to review the data, and we want to review the data for
benign tumors.
Benign tumors. All right. So that's cancer _ B data dot head, and this shows us the first 5 rows. There's a lot of stuff in there.
Yeah, there's texture, radius,
perimeter, compactness, concavity. Some of these make a lot of sense. I've talked to some doctors where they say the more spiky a tumor it is, the more likely it is to be cancerous, because that's an indication of how much blood flow it's trying to reach out and grab.
So it's trying to grow.
Yeah, so the more star-shaped it is, the more likely it is to be malignant. But that could be wrong. That's just a very, very oversimplified.
So that would be concave points and concavity.
Yeah, you see a lot of these are different metrics of how rough or spiky the texture is.
Okay.
Even down to like fractal dimension.
Let's see
so
for malignant.
Yeah. So cancer data dot head. Okay. So let's just see. Okay.
So I see that the concave points are a little larger than compared to.
Actually
a large.
They're a lot larger, yeah. And yeah.
Interesting. Texture almost seems. Oh, well, actually, in malignant textures.
Well, and that's the texture worst, which I don't know what that means.
So there is a mean value.
Yep.
And then there is a worst value.
Do you think that's if somebody has more than one tumor? Like each one of these is a patient ID, and this is like the.
It could be, or it could also be each tumor will have, if it has multiple spikes, like you say, there might be some areas which might have. It might be defining different areas within the same tumor as well.
Okay.
That this one has this much texture, this side has this much texture, and out of them the worst one is this one.
Yeah.
And that's possible too.
If you know which answer it is, leave a comment and let us know.
Yeah, because this is just a guess from me. I haven't studied breast cancer tumors.
Yeah,
so
I mean, from this image, if we're seeing that there's more than one tumor, then that could be one. But if you say this is all one tumor, and then like Ravi was saying, you have like sub-classifications for each one.
Yeah. Let us know if you know the answer. I would be really interested in finding out.
Yeah. Alright. Alright, so now in the first 5 rows of the data for benign tumors, what is the largest value for perimeter? So we gotta go up here. 87.46.
Yes.
So, I mean, this part is really just saying, look, you can get information from this. Alright, what's the radius for the tumor with ID 842517? Okay, the radius.
20.57. I think it's also trying to get us into the habit of trying to read what the head.
Yeah, and kind of doing a
provides.
sanity check of, does this make sense? Like, one thing that's not provided in here is what the units are.
Yeah.
But I'm assuming that it's millimeters.
Yeah.
That's just a guess, though.
It might be even less than that. Millimeters would be 20 millimeter would be a very big tumor.
True. Let's see. Alright, so use the code cell below to create two histograms that show distributions and values for the area for both benign and malignant tumors. Create a single figure containing both histograms in the code cell below. Okay. So I go SNS. I'm gonna guess that there's a histogram.
Uppercase H.
You think it's uppercase H?
Not really sure.
Let's see what pops up.
Yeah, actually that might be
So if I go, yeah, weird. There's nothing under.
So apparently it's dist plot.
Oh, dist plot. Okay. And then I guess you just need the one value. So you need the cancer B data
And area
area mean. Okay. And then we need that same thing for cancer M data. But will this put them on the same plot? Apparently it does. So yeah, so it looks like there's a much broader distribution for the malignant data, but in general, they've got a larger area.
Yeah.
Okay. Now, let's see. A researcher approaches you for help with identifying how the area column can be used to understand the difference. Based on the histograms above, do malignant tumors have higher or lower values for the mean area relative to benign tumors on average? And which type seems to have a larger range of potential values?
So the higher value in area mean is for which one is the orange one? That's
we didn't put a legend on there.
no, we didn't.
But I'm gonna go ahead and let's look at
Just comment out one of them, the malignant.
Oh, okay, that's a good.
Okay,
So that's
benign is blue.
and it has a median mean of about 500.
Yeah.
So we have that back. Yeah. Okay. So yeah. So this blue is the benign, and the orange is the malignant.
So malignant has a much higher value of area mean.
And it also has a
Much broader range of values in which it can be. So yeah.
Yeah. So like we said,
We can have the solution.
deleted the wrong part there. All right. So malignant tumors have higher values, and they have a larger range of potential values.
Yeah.
Alright. So use the code cell to create 2 KDE plots. KDE, what does KDE stand for? I don't know. We're gonna look it up.
Kernel density estimate.
Kernel
Density
estimate. Okay.
Yeah.
All right. I can
That is
get down with
kinda
that. I can get down with that. Let's see if. Apparently, that's a lot easier to find than a histogram. And we're gonna do again the same thing. Cancer B data. Radius worst. And then KDE plot. Cancer M data. Radius worst. We'll run that.
It does show 2 plots.
It does show 2 plots. What are we doing wrong here?
Maybe shade equal to true.
Oh, shade equals to true. That's the problem with automatically
Yeah.
graded assignments. There we go. That was it. You win the prize, Ravi. I don't know what it is, but you've won it.
Yeah, I think it was just rather than just showing the line, it's showing the entire area within that.
Mm-hmm. Oh, and this is how you would add the
You can put label.
legend. Yeah, you can label each data set. That's nice. So we cheated and we open up the solution to see what they did that maybe we didn't. Apparently the basic was just the shade true, but the label is pretty easy to add on the plot too, so that's nice.
Okay. Hospitals recently started using an algorithm that can diagnose tumors with high accuracy.
Alright, given a tumor with a value for radius worst of 25, do you think the algorithm is more likely to classify it as benign or malignant? Probably malignant.
Yeah.
Yeah.
Malignant.
Yeah, looking at this, it has the same distribution that the area does, where malignant has a higher average and a wider or a broader
Range.
Yeah. All right. I feel like that was pretty fast.
Yeah.
So I feel like we can hop into the next one, which this is the choosing plot types.
That should be fun.
Yeah, this may be a quiz. I don't know. Let's see, go back to the home page. Let's see, here we go. They wanted us to read the documentation before we started running the code.
Yeah.
I think I may have done a portion of this one simply because I knew it had some cool graphs in it, and I needed some for one of our events one time.
Oh. Okay.
So we'll see.
That works.
All right. So again, we're just setting up the page. So we'll run that cell. All right. Setting up the learning tools. Alright,
Yeah.
run the next cell to load the data. So we're going to load. So in this case, we're loading Spotify data. So we're actually seeing how many times songs were played, that kind of thing. Alright. So now. Alright, so we're working with a chart from the previous tutorial. Run the next cell to load the data, okay. So now we're going to create plot.
What is set style dark? It's the background.
Yeah, I guess it just made it.
What does light look like?
I don't know, because that doesn't look like a dark themed.
I mean, it's. Did it plot anything?
Style must be one of white, dark, white grid, dark grid. So we'll call it white.
Shouldn't it be white? Yeah, it's the background.
Yeah.
Dark had a bluish thing, but it wasn't particularly.
No. Especially not when you're used to looking at dark theme browsers and everything. Alright. Is that all that's in here? That's all that's in here.
Really? Just the style? This one style?
Yeah, just the one style. Okay, so that's just
maybe
calling different themes. But yeah, let's go back and look at the other page. Alright.
That was fast.
Yeah, that's really fast. Okay, so let's look.
So yeah, I mean that's a basic summary of what all we did in SNS.
Yes. Yeah. So yeah, it's a nice summary of okay, what kind of data do you have? And what kind of information are you really trying to show?
Yeah.
I don't think we made any joint plots.
Yeah, we didn't make any joint plots. That's the only one I see that I don't remember.
Yeah, I can't.
I remember heat maps, bar plot, scatter plot, swarm plot.
Yeah.
Reg plot, IM plot.
And the line plot, yeah.
Disk plot and KDE plot we did today. Oh, no, disk plot we did earlier. But KDE plot we did.
No, this plot we did today, because that's.
Yeah, that's true.
So if you want a distribution, then you go to one of these yellow ones like KDE plot or disk plot to really show kind of the histogram and the density of your data points around certain values. If you're looking at relationships, then you want some type of regression or heat map to kind of pull those things together.
Yeah.
Or like box plots or swarm plots. And then if we want to see like trends over time,
scatter
then
plot.
the line plot and other scatter plots in that.
Scatter plot, reg plot, and plot this might be.
Well, those are also saying that they're under the relationship. But I agree, it's still looking at trends. So I think this is a mild oversimplification of the categories. But yeah, it's pretty good. That's pretty good. Let's look down and see if there's anything else we need to snag. You can always, of course, read in your own CSV file instead of reading in.
Yeah, this one was just supposed to be.
Yeah.
I wonder what is the joint plot. Maybe we can try it on one of the data
So the
sets.
joint plot is is two variables. It's kind of like you're looking at a histogram on two different axes. So if we come back to the distributions.
Yeah, it might be fun to try it.
And we do. Let's just come in here.
Oh, we'll have to rerun this.
Just make a. I don't think we have to rerun it because I didn't get out. Let's just insert a code cell. Where did it go? Oh, right there. Alright, so then, let's see, what is it? Joint plot?
Yeah, SNS.
So SNS dot joint plot. And on one side, we're going to do cancer M data. And we'll do area mean on one, and then we'll do radius worst on the other.
Okay.
And then I'm assuming we have to put in 2 different things here. And I'm also assuming you have to have the same number of data points because each data point has to have both things associated with it, which is why I don't think we could easily do the benign and the malignant tumors on the same plot. So we'll do radius worst. Let's take a look at that. Okay. So clearly there are some other options that we would need to put in if we wanted to get this green one that they're showing here.
Yeah. Let's just take a look and Google what are the options with joint plot.
Okay. Let's see. SNS joint plot options. So let's see. It looks like it defaults to a scatter plot, but I think if we called it, do you think KDE?
Maybe.
Let's try that.
Comma kind
equals KDE.
Yes.
Yeah. Okay. Yeah, that's a really cool looking chart. I like that one. So that looks like that's really nice when you're looking at the interaction of 2 variables.
Yeah.
And how they're related. So that's neat. I don't think I've ever made one of those before.
Yeah, but it looks really nice.
Yeah. I don't know what I'm going to use it for, but it looks nice.
It's true.
So, all right, cool. Well, until next time, guys, unless there's something else you wanted to...
No, that was
check
basically
out.
it. I mean, just try out these graphs with the data sets that you guys have and let us know how your experience is.
Yeah, and come into office hours. We're happy to talk with any of you guys about what your experience is with this stuff and how to use it for your data.
Yeah, and if you know of any other libraries that do a better job than Seaborn or make more prettier graphs or more informative graphs and you want to come and talk to us about it, we can actually have a session with you as well, one of these data science sessions, including you. So
yeah, absolutely. All right, well, awesome. Well then we will talk to you guys next week.